Here's Io. This is a moon of Jupiter. Io is one of the most volcanically active system in our entire solar system. Extremely there's lots of volcanoes going on here. Lots of volcanoes. And the reason why is because Jupiter tugs on this moon. And the tugging of it, that tension, that friction, called tidal friction, generates enough heat to sustain volcanoes. And that's why it has volcanoes. It also has a small core too, but a lot of it has to do with the friction. Let's see. Ooh, here's Europa. Europa is another moon of Jupiter. And the surface of Europa is covered in a thin layer of ice. And again, with the friction between the planet and the moon, it causes the heat to generate. And it causes this ice to crack and melt and shift. It causes water to get in the cracks. So the crust is fractured, right? And the cracks are filled with water, and then they freeze over because they're so cold. They freeze over instantly. Water cannot exist on this type of environment. You can't have water. There's not enough pressure. There's not enough air. There's no air. So once water gets up enough, it freezes and becomes this. And that's happening all over and over and over again. At last, here we are, Enceladus. Look at this gorgeous guy. This is Enceladus. A real picture. This is a moon of Saturn. And the surface is covered in snow. This is a winter wonderland world. And the surface is covered literally in snow and ice. And it's about 30 miles thick of ice. 30 miles of ice and snow. Now, why is there snow? Well, under that ice is a liquid ocean. Europa has tons of liquid water under the ice. And that water is warm and salty, just like the Earth's water. Okay? So it's like a big snowball, a wet snowball, right? But how does this surface continuously have soft snow on it? Well, the reason why is because a lot of that water shoots up from geysers, spewing water out into space. Some of it goes into space, but some of it slowly drifts back onto the surface. And it's continuously growing in its snowiness. And it also has cracks where water can, seep up but then freeze over. But sometimes you have geysers. And here's a great example of one. If you see, that water is being spewed out into space. And we had one of our probes called Galileo and Cassini flew by this moon and scooped up some of it and tested it to see what it was, and analyzed that water, and it found water It found CO2, it found stuff that we found on Earth, and even amino acids. We found amino acids on this moon. Amino acids, the building blocks of life. So under the surface of the ice and the water, there could be volcanic vents. There could be hydrothermal vents, which we know on Earth are the great environments for life to thrive. So just imagine deep down under this ice, we find living organisms, perhaps fish. There could be all kinds of fishy aliens swimming on the bottoms of those oceans. We don't know what's under there. We have no idea what could be under the ice. But there's no way we can go there right now. It's too thick. It's too harsh of an environment. Here's Titan, another moon of Saturn. Titan is another amazing moon because it has liquid on its surface, but not water, methane. On Earth, methane's a gas because it's warm enough to be a gas, but on Titan, it's way too cold to be gaseous. It's liquid. So it has liquid methane running upon its surface. It also has a very thick atmosphere. In fact, Titan's atmosphere is thicker than the Earth's. Nitrogen, ammonia, all these types of gases that we find on Earth, it even has a thicker atmosphere. Another prime example of a planet where life could be thriving. It has liquid. Liquid is something important. It has enough energy it's conducive to life. So we haven't even attempted exploring these worlds. We still don't really know what's there. But just think of how exciting it would be to figure out what is there. These are 3 potential places where life could be in our own solar system, right? There could easily be life on Enceladus. There could easily be life on Titan. There could easily be life on Europa. But unfortunately, we don't have enough people that care to look for it. Let's see here. Oh, we got some more galaxies. Ah, yes, look at those spirals. Remember, every single dot you see is a star. And each star has at least 4 or 5 planets orbiting around it. Now, at the center, at the galactic center, there's a supermassive black hole. Millions of solar masses, but maybe a few light years, maybe the size of our solar system, but the mass of millions of stars. So black holes are extremely small, but extremely dense. And that's why they typically are found in the center of galaxies. They hold the galaxy together. You also see around the black hole, the galactic center, there's tons of activity going on. There's tons of large stars, supermassive stars, orbiting very closely to the accretion disk, a very, very, very energetic area. Lots of heat, radiation, gases, and stars, orbiting very quickly around the center. But then you have spiraling out all these arms of the galaxy. Yes, dark matter holds the galaxy together as well. We don't see dark matter. Dark matter isn't visible to the naked eye or any eye. It's not visible with light at all. But it has a gravitational effect. If you had a bunch of dark matter in your hand, it would not interact with your hand either. It would just go through your hand, sink even towards the center of the earth. It would sink below the earth because it doesn't interact with matter. dark matter doesn't interact with regular baryonic matter, the matter we're made of. So you couldn't hold it in your hand. It would seep through your hand if you had it in front of you. But the beauty of this is that dark matter is found all around the galaxy. There's some dark matter going through your body right now. But there's a lot of dark matter. In fact, most of the galaxy is made of dark matter. Most of the universe is made of dark matter. Not our type of matter. We are the rare type of matter. Most of the universe, about 80% of it, is made of dark matter. We can't even see it. But we feel its effects. And dark matter is kind of like this bubble that surrounds our galaxy and fills our galaxy and keeps it gravitationally together. Now, you might think that when scientists look at the speed at which these galactic arms spin, we would have expected them, given what we know about regular matter, we would expect them to be slow. We would expect them to slowly evaporate over time. Well, we don't see that. We see these even the most outer galactic arms spin fairly quickly relative to the center. So all the speed is evenly spread throughout the galaxy. What accounts for that? Dark matter. Dark matter is what holds the galaxy together. So that's amazing. And there's all kinds of galaxies. There's elliptical galaxies and irregular galaxies and clumpy galaxies and all kinds of here's one. It's just a more circular galaxy. This is a backward spiral. And here's a picture. This is a gravity cluster. This is a cluster of galaxies. Each one of these dots is not a star, an entire galaxy. When we look at these pictures, these deep pictures of space, what we see, if you notice, are these little weird lines. You guys see that? Those weird lines? You guys see them? Little weird squiggly lines. Those are real things. They really happen. We really see these weird lines. Now, the reason why it's not a smudge on the screen, it's not a smudge on the telescope lens, it's really there. There's really this squiggly line. That's what you would see if you were to look at it with your eyes. But why, right? The reason why is because although we can't see them, black holes, dark matter fills the universe. There's lots of black holes around us. All kinds of black holes and dark matter clumps that distort space and time. They distort space and time. We don't see it with our eyes because they're dark. But they distort space and time enough so that light that is moving past those gravitational fields of those black holes, that light distorts. It traverses through space and time in a straight line, but the space and time that it moves through is warped. So from our telescopes, it looks like this light is being warped. And this is called gravitational lensing. Okay? And this is a prime example of what dark matter, how we know dark matter exists, how we know black holes exist, because we see these lines of light. And that's clear evidence that something's there. We just don't see it. But something gravitationally massive is there. So, yeah, dark matter is still a mystery. We still don't really know what dark matter is. But the more we look out in the universe, the more we'll figure the answer. So much mystery. I want answers. Well, the beauty of life is that it is mysterious. When you embrace what you do know, when you embrace what is known, you begin to embrace the mystery, what you don't know, right? That's why I enjoy science, because that's why I enjoy enjoying science, because every time you do it, you appreciate things more. You appreciate what little we do know more, right? The little candle in the dark is what we see. So we're kind of like in this dark cave with a little candle going, okay, what do we see? You just want to see the rest of the cave, but you're forgetting the light is illuminating little bits of it. And what we're finding is little bits and pieces of the cave. And that's the beauty. That's what science is all about. It's about building up this puzzle, these puzzle pieces, to figure out what it's all about. And so it's on both sides. There's goods, right? There's appreciation on both sides. The universe is so huge we can't even comprehend its size. Exactly. We don't know how large the universe is. But again, at the end of the day, no matter how large the universe is, no matter how infinite it is, all we have is each other. Your friends, your family. That's it. So, that's why I don't, all the mystery doesn't bother me. Right? That doesn't bother me. In fact, I embrace the mystery. I love the mystery. I enjoy it. It gives us something to look forward to. But at the same time, everything I need and want is here. People around you, the things you do, the world around you, the earth, nature, people, animals, trees. There's so much to appreciate. And that's what gets rid of the itch, right? You appreciate what you have, what you do know more, because there's a lot we've known. There's a lot of things we actually have discovered as humans. There's a lot of things we've discovered. There's a lot to wrap your head around. So you should do that before you skip ahead and go, what else is out there? You should let everything we do know sink in. Then the itch will be gone.